Okay, so today we are going to work on day 5, which is the standard form of a line versus slope y-intercept form. So we know that the standard form is going to look like ax plus by plus c equals 0. It's always equal to 0 for standard form. Slope y-intercept form is going to be y is equal to mx plus b. We know that the slope y-intercept is more useful because it tells us the slope, how slanted the line is, and the y-intercept. So as a practice, let's start with number 1. So we want to rearrange in the slope y-intercept form and then sketch, because for standard form we don't know the pattern of how the line is going to look like. So I want to isolate for y, so I'm going to move 3x and negative 8 to the other side. So y is equal to negative 3x and then plus 8. Now we know that we can label our y-intercept, our starting point is 8, and my slope is negative 3. Now I could put negative 3 as negative 3 over 1. So what does that mean? The translation is that it's going to be rise, slope is rise over run. So therefore, if I have negative at the top, it will be going down 3, or we could go right 1, or you could put negative at the bottom. So that means we will be going up 3 and we will be going left 1 if we are putting the negative at the bottom. So keeping that in mind, let's start. So I'm going to label my y-intercept 2, 4, 6, 8. This is my starting point, which is 8. I will be going down 3 and then to the right. So let's start. So 1, 2, 3, and then we're moving right 1. So this is my point here. And then again, I can go down 3 again. 1, 2, 3, and then right 1. And there you have it. So when you are drawing a graph or a line, I need to see 3 points, and make sure you use a ruler and label your arrows both ends. Okay. Now let's do another type of practice here. So we are given a graph and a standard form. So let's take a look at number 5. We want to convert it in a slope y-intercept form by rearranging it so that we can identify the y-intercept and slope much better. So let's do the calculation. So 5x minus 2y minus 4 equals 0. I want to isolate for y, so I'm going to move 5x, or actually I can move negative 2y to the other side. So I have 5x minus 4, and on the right side I have now positive 2y. So let's divide everything by 2, so it cancels out. So therefore y is equal to 5 over 2x. So I want to rearrange it so that it's slope y-intercept form. So y is equal to, I'm going to write the slope first, 5 over 2x, and then my y-intercept. So just by looking at it, I know my y-intercept is going to be negative 2. Slope is going to be 5 over 2, which is 2.5. Okay, and then, so there you have it. Okay. Now, let's say you were given a slope y-intercept form, and I want you to convert it into standard form. Well, what you can do is you should be moving everything to one side so that it equals 0. So I will be moving y to the right, so then 0 is equal to, so y now becomes negative y plus 5 over 2x minus 2. Now within a standard form, we don't want to have a denominator or fraction. So find the denominator. In this case it's 2. So we're going to multiply everything by 2 so we get rid of the denominator. So therefore 2 times 0 is 0. 2 times negative 1 is negative 2y. Now we have a fraction here. So it's 2 divided by 2 is 1, and then times 5, and then 2 times negative 2 is negative 4. Oh, don't forget x here. So 0 is equal to negative 2y plus 5x minus 4. But I like to put it in alphabetic order. So it's going to be 0 equals 5x minus 2y minus 4. And this is my standard form. Okay, so remember standard form, the equation has to equal to 0 and there should be no fraction. Now let's try a different type of question this time, number 8. So we have the line y is equal to 4x plus b. It passes through a given point and they're asking us to find the value of b. All you need to do is, let's plug in a point. 8 represents x and negative 3 represents y. So I'm going to plug in negative 3 into y. So negative 3 equals 4 times 8 plus b. Rearrange. I'm going to move 32 to the other side. So therefore, we were able to isolate for b by plugging in the coordinate xy. Okay. Now let's try to do a word problem. So number 10. So Dawson knows that the formula for the perimeter of a rectangle is p is equal to 2l plus 2w. So he has 180 meters of fencings to enclose a rectangular play area with a maximum width of 32 meters. What is the minimum length of the area? Okay, so it looks like we are given a perimeter because 150 meters is a fencing that you are putting around the shape, which defines the perimeter. So P is 180 meters, and we're also given the width, which is 32, and we are looking for the length. So I will be plugging in the given information into the formula. So P is 180, 2L plus 2 times the width. Let's simplify. And I'm going to collect the like terms by bringing in positive 64 to the left side. So it becomes minus. And let's divide everything by 2. So therefore, the length is 58. So therefore, what is the minimum length? Minimum length, don't forget the unit, is 58 meters. Okay, good. So it's the same idea here. You will work on these word problems. Now let's try some more challenging word problems here. Okay, so number 1. So John bought a new television. The total cost includes a delivery charge of $120 plus taxes of 13%. So create an equation by having a let statement. So let's start with that. So it looks like we are given two variables. We have to use two variables. So let x be the cost of the TV, right? We don't know what the TV is. Let x be the cost of TV, and let y be the total cost. So if we have to write this, we have y is equal to, so it looks like there is a delivery charge. Delivery charge is sort of like a one-time fee, which is x plus 120, right? It's a one-time fee. And then you are paying taxes of 13%. So whatever the cost of the TV, including the delivery, you are going to multiply by 1.13. So when you multiply by 0.13, you get the taxes, okay? Just only the tax. But when you multiply 1.13, you are getting the total price including the tax. So if you are curious at a store, grocery store let's say, and you want to figure out how much taxes you're paying, just taxes, you're going to multiply the cost with 0.13. But if you want to figure out what is going to be your total cost, including all the tax, then you're going to multiply 1.13. So there you have it. So we have an equation. But for letter B, it says determine the cost of the television before the delivery and the taxes if the total cost was $540. Okay. So what we know is that the total cost is going to be $540, and we are looking for the cost of the TV, X. So let's plug in our number. So 540 is equal to 1.13, and then X plus 120. So what we need to do, because we have a bracket, I would recommend that you could divide both sides by 1.13, okay? Or you could do a distributive property, okay? So let's say you decide to do distributive property, if you like. So you can distribute. So you will get 540 equals 1.13x plus 135.60. And then collect the like terms. These two are numbers. I'm going to move it to the left side. And then after that, isolate for x by dividing by whatever it's in front of x. So therefore, x is equal to, so I put it into decimal because it's money. So just keep that in mind for word problems. So therefore, how much is TV? TV costs $357.88. Okay. Okay, good. Now let's try number 3. Number 3, let's see. So Ted and Ben are swimming laps in a pool that is 50 meters in length, and they start at the opposite end of the pool at the same time. So Ted swims 10 meters per minute faster than Ben. So after 2 minutes, they swim by each other. Okay, so just right away, this number 3, it involves a word problem that involves speed. So what I'm going to do is, you need to remember the speed formula. Speed is equal to distance over time. Okay, therefore, I would recommend that you make a chart. So one chart is for Ted, and the second one is for Ben. So let's do distance. We have time and we have speed. So for distance, we know that for time, they are taking them, so after 2 minutes, they swim by each other. So for both Ted and Ben, the time is 2 minutes because they're swimming 50 meters. And then for, let's say for velocity, or for speed in this case, Ted is swimming 10 meters per minute faster. So that means Ted will be, let's say, we could say let X be, let's say, the speed of Ben swimming. Okay, so that if Ben is swimming at, let's say, X, then for Ted, it's going to be X plus 10, because Ted is swimming 10 meter per minute faster. Okay, and then to find distance, all you need to do, rearrange distance formula. D is equal to speed times time. So what I'm going to do for Ted, I'm going to multiply 2 times X plus 10 by using the formula. Okay, and for Ben, it's going to be speed times time. So 2 times X, which is 2X. Okay, so let's formulate an equation. So we could say that for total distance, we know that they are swimming 50-meter length pool. So therefore, for the Ted, for the distance, it's going to be 2x plus 10. And for Ben, it's going to be plus 2x is equal to 50 meters. Okay. And remember, they are starting at the opposite end at the same time. So we do have to add, they are meeting at one point after the 2 minutes. So after that, we are going to solve for X. So let's rearrange. So I'm going to distribute. So it looks like I have a like term here. And I'm going to bring positive 20 to the right side. So therefore, X is equal to 7.5. So what does that mean? So therefore, Ben is swimming at 7.5, it's meter per minute. And then Ted is swimming at, so we will have to plug in 7.5 into X over here. It's going to be 17.5 meter per minute. Okay, now the let statement, always remember, is coming from where the question is asking, what the question is asking. The question is asking how fast is each person swimming. So therefore, that's why I said let X be the speed of Ben. Okay, so keep in mind when we are working with a distance and speed, time, word problem, I would highly recommend that you make a table like this, separating each person, and use the formula and then to identify, formulate an equation. Okay, so let's try number 5. It says, Flight 47 leaves Toronto Pearson International Airport en route to Vancouver. So it travels at a distance, average speed of 500 km per hour. 1 hour later, a cargo flight leaves Pearson for Vancouver, traveling at an average speed of 750 km per hour. Let T represents the time in hours. And solve the equation. Oh, okay. So this question is a little bit easy because it gives us the equation. And all we need to do is we need to solve for T. So let's plug it in. So let's see. If we are given 500T equals 750 T minus 1. So it looks like we have only one variable, so we can isolate. So before I do that, I would like to do the distributive property. So then it's going to be 500 T equals 750 T minus 750. So let's collect the like term. So I'm going to subtract it. So I will get negative 250 T equals negative 750. And let's divide both sides by whatever is in front of T. So it cancels out. Therefore, t is equal to 3. Okay, so therefore, how long it's going to take to find out when the cargo plane catches up? It's going to takes 3 hours because the unit is in hours, right? And that's how it will catch up. Now let's try to do a word problem number 8. Okay. Now the graph here shows how the total cost in dollars to ship workbooks related to the number of workbooks. So write an equation in the form of y is equal to mx plus b for this relation. Okay, I see. Now in this case, we're given 2 points. So first step, I would recommend that identify a y-intercept. And it looks like my y-intercept is touching over here. And each square is going up by 25. So my y-intercept is 25. And to find slope, I'm going to use y2 minus y1, x2 minus x1. So I could say this is x1, y1, this is x2, y2, plug it in, and I get, when I simplify, 70 over 20, which is 7 over 2. So the equation, in this case, y is equal to 7 over 2x plus 25. Now what are the values of m and b? Well, it looks like in this case, look at the units. It's dollar per the number of workbooks. So the slope must be representing, which is over here, 7 divided by 2 is 350. So that means it's going to be $3.50, which is dollar, which is the y value, per the number of books, which is per each workbook. So that is the slope. So each book is going to be 350, and then our y-intercept in this case is going to tell us the initial cost to ship the workbooks. So it will be initial cost. So Ji-yoon has a budget of 200 for the workbooks, and they're saying how many can she buy? So it looks like we are going to look for X, which is the number of workbooks, and we're given $200, Y value. So for letter C, let's plug in 200 into Y. And I'm going to move 25 to the other side, which is subtraction. So it will be or if you want, you could put it 7 over 2 as, let's say, just for simplicity, 3.5 if you like, so that you can punch it in the calculator much easier. So I'm going to divide both sides by 350. X is equal to, you get 50. She can buy 50 workbooks for $200.